this is the tutorial sheet. There are 5 questions. I will try to do as many as I can. Right. Let's start with question 1. So here you have where's my pen? Oh, here we go. All right. So you have 2 different types of stuff, and you want to test, and these are the data that's given to us. So you have 10 on type A, 12 on type B, and these are the sample means. And you're also told that the corresponding population variances are known to be this and this, right? Okay, so these are the population variances. And the question is to test this versus this at the 5% level of significance, right? Okay, so let's see how we can do this. Now, before I start doing this, let me show you the stuff I covered. This is the stuff I covered on the 2 sample confidence interval, sorry, 2 sample test of hypothesis, right? You may recall this. This is the case where you have 2 independent random samples and the population variances are known. And the rejection rules for this and this and this are these 3 respectively, right? And the second case that I considered while talking about 2 sample confidence intervals was this one, right? Here you have 2 independent random samples, and the variance is common, but it's unknown, right? And in this case, the rejection rules for this one, and this one, right? Right. And the third case I considered was the most general case, where you have 2 independent random samples, and here we are assuming that the variances are unknown, right, and not equal, right? And in this case, these are the 3 rejection rules, right? And finally, the final case I considered, yes, Heng, yeah, you're right. The 2 sample tests will not be in the exam, but nevertheless, I would like, I mean, for the sake of your knowledge, and it is important that you do learn it anyway, right? Okay. And the final case I considered, here we are testing for equality of proportions, right? So you have 2 independent random samples from 2 different Bernoulli distributions, and the 2 proportions are unknown. And these are the tests that we are testing for, and these are the corresponding rejection rules, right? Now, for question number 1 in the tutorial sheet, it clearly says that the population variances are known. For testing this versus this, clearly we need to use this case here. So this is what we need to use, right? So for testing this one versus this, we will use the rejection rule, which is this one, right? Is that clear to all of you? Yeah. Okay. Right. So that's what I'm going to do now. So let me show you. So this is question 1, part 1, right? The rejection rule that we're going to use is the following: we reject H0 if right. This is the rejection rule, right? Right. So let me, as I done before, let me put this in a box, right? Right. And let me call this star, right? Okay. According to the question, we are told that X bar is 11.4, and we are told that Y bar is 9.9. We are told that M is 10, n is 12, and we are told that, sigma x squared is equal to 6.25, and sigma y squared is 9. And also, we are also told that the level of significance alpha is 5%, so it's 0.05. So this is all the data that's given to us, right? Okay. Right, now let's compute the left and the right-hand side of star, right? So starting with the left-hand side of star, right? You should sub in the numbers, you should sub in these numbers into the left-hand side. This is what you have. Okay. Right now, if you compute this using a calculator, this will be equal to 1.279. So this is your left-hand side, okay? And the right-hand side of star, all right, which alpha is 0.05. So it's going to be Z or Z 0.95, which is 1.645. And clearly the left-hand side is not greater than the right-hand side. So the conclusion is that there is no evidence there is no evidence against the null hypothesis H0 that the population means are equal, right? Okay, is this clear to all of you or no? So I mean, this is similar to what we did last week in the tutorial, guys, right? It's just finding the correct rejection rule and then computing the left and the right-hand sides and compare them, right? So if the inequality is satisfied, then you say there is evidence to reject the null hypothesis. And if the inequality is not satisfied, then you say there is no evidence to reject the null hypothesis. Okay. All right, guys. So that's part one of question one. Part two, what is the probability that the test will correctly reject H0 if the true value for mu1 minus mu2 is 2? Right. Okay, let's see how we can do this, right? So let me get a paper. So this is question one. Question one, part two. All right. So we are looking for the probability that we will reject the null hypothesis when the difference between the two population means is equal to 2, right? Okay, right. Right, so now from the first part, we know that this is the rule for rejecting the null hypothesis, right? So this is the probability that x bar minus y bar divided by okay, right? Now let's put in the numbers that we have. We know that sigma x squared is 6.25. We know that m is 10, sigma y squared is 9, n is 12. And we know that the right-hand side is 1.645. Okay, all right, guys. All right, now to compute this, I'm gonna do a trick which is similar to something I did last week. I'm gonna subtract 2 and add 2, so I haven't changed anything, right? Come on, if you have questions, feel free to use the chat room. Okay, guys, I'm happy to answer all the questions you guys have, right? Right. Okay. Now the next thing I'm going to do is I'm going to take this 2 here to the right hand side. So this will be okay. Right, now let me ask you a question. What do you know about this? Can you tell me something about this, guys? Hello, guys, talk to me. What is N01? Why is it N01? Why is it N01? The reason it is N01 is because I don't know whether you remember something I did before when I talked about 2 sample confidence interval. One of the results I mentioned is the following. That is, let me write it down if I have space here, right? That suppose you have 2 random samples, right? So this is a random sample of size N1, which are IID from this distribution, right? And you have a second random sample, which is like this. Yeah. So, and suppose these 2 are independent. Suppose these are independent in independent random samples. Right, then one of the results I mentioned earlier, I mean, you may recall, if you look back in the 2 sample confidence intervals video, you will see the following. This is the sample mean for the first sample. This is the sample mean for the second random sample. Take away right? This guy has the standard normal distribution. Let me put this in a different color. Right. So this is I mean, once again, I mean, this is a result I mentioned earlier in one of the videos on 2 sample confidence intervals. So If you can't remember, please look back in that video. Okay. All right. So using this result, we can argue that this guy conditional. Sorry. Conditional on mu1 minus mu2 equal to 2, this guy has the standard normal distribution, right? So hence, the probability is n01 greater than 1.645 minus 2 divided by the square root of 6.25 divided by 10 plus 9 divided by 12. Okay, guys? Are you with me so far? Let me know. If you're not, please ask, right? Okay. And finally, this you can write as 1 minus 5, yeah. Right, and if you compute this using the normal table, or some other way, this is what you will get, 0.52, right? All right, guys. So are you okay with this or not? Hello, guys. Talk to me if you're not okay, please. Are you guys okay with this? Yeah, sure. Okay. All right. So that's question 1. It took us a long time to do just one question. Okay. Let's see how we can do question 2 now. Question 2 is this. We have 2 different types again, and these are the sample sizes. These are the sample means. And here you are told that the common variance is this, right? You're given a common variance. Which is known, right? It's a non-common variance which is equal to 1.742, right? And the first part is asking you to test the hypothesis whether there is a difference between the means for type A and type B, right? At 5% level of significance, right? So let's see how we can do this, right? So as you can read this, it says test at the 5% level of significance level whether there is a difference in the mean for the types A and B, right? So this case is once again, you should go back to the formula sheet. This is the formula sheet. This is once again corresponds to the case where the population variances are known, right? So, but in this case, the population variances, besides being known, they are equal, right? And the thing that we're trying to test is this hypothesis, right? Which is the rejection rule for this hypothesis, right? Okay, so all right. So let me write down the rejection rule. So this is question 2, part 1. So we reject the null hypothesis if, according to the formulas that I gave you, right? This is the rejection rule. This is right. The 2 sigma squares are the same, right? Because the question says so. If you read the question one more time, it says that there is a common variance which is known to be equal to 1.742, right? So this is the This is the rejection rule, guys. Okay, let me put this in a box. Right. All right, and let me call this star, right? So what I'm going to do is, as before, I'm going to compute the left and the right-hand side. Before I do that, let me write down what is given to us, right? What is given to us? We are told that X bar is equal to 10.24, Y bar is equal to 9.76, M is equal to 25, N is equal to 25, and sigma squared is equal to 1.742. So this is all the data that we are given, right? So using this data, we can compute the left-hand side of star to be equal to right? All right, now if you work this out using a calculator, this is what you will get. Okay, now the right-hand side of star is, remember, we are using alpha 5%, I think, right? Yeah, 5%. So the right-hand side is Z 0.975, which I'm sure you know how to read this, is 1.96. So this is the right-hand side, and this is the left-hand side, right? Okay, guys, and clearly this is not greater than 1.96. So the conclusion is once again that there is no evidence to reject the null hypothesis. All right, guys, are you okay? Are you okay with this or not? Hello, guys, talk to me. Are you okay with this or not? This is part 1 of question 2, right? Now, all right, now part two of question 2 is asking you, what's the probability that the test will incorrectly fail to reject the null hypothesis if the true difference between the mean is 1? Right, so what the question is asking you is the following. So this is question 2. This is question number 2, part 2. The question is asking you for the probability that you will accept the null hypothesis when the difference between the population means is equal to 1, right? So that's what the question is asking you, right? Now this, remember, this is the rule for rejecting the null hypothesis. So the rule for accepting the null hypothesis is the opposite of this rule, right? Which is right. Now, okay, the first thing we must do, before I do that, okay, let me put in the numbers, right? Let me put the numbers in, right? Sigma squared, we know is what is 1.742. 1.742 divided by m, which is 25, right? This is less than or equal to. Now, if alpha is 0.05, this guy is 1.96. Okay. All right, guys. All right, the next thing I'm going to do is, I think I mentioned this before. You should have something like, say, absolute value of z greater than, oh, sorry, less than or equal to a. This is the same as saying that without the absolute value, z will be between minus a and plus a. Did I not mention this before? I mean, I think I did, right? This is something you should know, right? If the absolute value of a number is less than or equal to a, right, then without the absolute value, z lies between minus a and plus a, right? So that's what I'm going to use in the next step, guys, right? So what you have here is an absolute value of something, right? So taking that away, okay, this is what you have, right? Okay, now the next thing I'm going to do, because the true difference between the population mean is 1, I'm going to do the trick that I applied in the previous question, you may recall. So what I'm going to do is I'm going to take away 1 and add 1. Yeah. All right. The next thing I'm going to do is I'm going to take this one here to the left-hand side and the right-hand side of the inequality, right? So you will get the following. You will get if you don't follow, please feel free to use the chat room, okay? If you don't follow me. All right, guys. All right, and in the next step, in the next step, I'm gonna make the argument that this guy here, right, has the standard normal distribution, condition on the fact that the true population, the difference in the true population means is equal to 1. This is the same argument. This is the same argument I made earlier. You may recall. This is the argument that I made earlier. Because of this result here, right? We can say that this thing, right, must have a standard normal, right? So this is the same as the probability yeah, less than or equal to okay. All right, guys. And in the next line, I'm gonna write this guy here as the difference in the phi function. So this will be capital phi at 1.96 take away okay, then minus capital phi all right. Okay, now if you work this out using a table or some other means, the answer that you will get is 0.24. All right, so this completes question number 2. Are you okay with this or not? I mean, if you're not okay, just feel free to say so. I mean, I'm happy. I really want to help you guys. I mean, you sure? Are you guys okay? Serious? All right. Okay. Let's move on to the next question. So we're done with question 2. Question 3. Question 3 is this one. You have two different drugs, drug A and drug B. And the first drug is given to 33 people. The second is given to 37 people, right? Okay, and these are the data that you have. So you have, these are the sample sizes, these are the sample means, and these are the sample variances, right? So we are assuming that they're normally distributed, and we want to test at 5% level of significance whether there's a difference between the mean times to absorption of the two drugs. And there are two parts. The first part is assuming that the variances are not equal. The second part is assuming that the variances are equal, right? Okay. All right. The first thing we need to figure out is which rejection rule that we need to use. All right. So let me go back to the formula sheet. So here we are. Remember this is the formula sheet I showed you earlier. Clearly, these rules cannot be used because the population variances are not known in this case, because the question gives you the sample variances, implying indirectly that the population variances are not known. So none of these rejection rules can be used, right? All right, now let's go back to the next page. Can we use these rejection rules? I mean, these rejection rules can be used only if the variances are equal, right? But for the first part, we are assuming that the variances are not equal. So these cannot be used, right? Okay, let's go to the next page. Let's go to the formulas here. In these formulas, right here, we are assuming that the variances are unknown, right, and not equal. So maybe one of these rules can be used. I mean, since we are testing for equality, since we are testing whether there is a difference in the mean times, the rejection rule that we need to use is this one, right? Okay, so we will use this rejection tool, this one, to do part part 1 of question 3. Right, guys? Is that clear? So you need to figure out which rule is the most appropriate rule to use, right? So that's really important for any question on hypothesis testing. All right, so we're gonna reject H0 if yeah. So let me put this in the box one more time. Okay, right, and let me call this star, right? So I'm going to compute the left and the right hand side of star, right? Let me take this away, sorry. All right, before I do that, let me write down what is given to us, okay? We are told that x bar is equal to 28.2, y bar is equal to 30.7, m is equal to 33, n is equal to 37, sx squared is equal to 16.36, and sy squared is equal to 18.92. Right? So this is all the data that's given to us, right? Okay, so given this data, that we can compute the left-hand side of star to be equal to the following. Sx squared is 16.36 divided by m is 33, 18.92 divided by 37, right? Okay, and if you work this out, using a calculator, this will be 2.49. So that's your left-hand side. Now the right-hand side of star, okay, is gonna be, all right, this is why we have a problem, because remember, A is a very complicated formula. If you go back to the formula sheet, you may recall that the formula for A is this very complicated formula. So if we can, we would try to avoid using this formula. Right, now let me show you, because alpha is 5%, right? So what you have is TA at 0.975, right? Now, I think I mentioned this to you guys before. If you look at the sample sizes, you have 33 and 37, which are large, because I think I mentioned to you before that anything above 25 is considered large. So certainly 33 and 37 are large sample sizes. In this case, you can approximate this percentile by the Z percentile. That's because this is allowed because of the large sample sizes, right? Okay, and this will be equal to, you should read this off. I mean, this is much easier to read from the normal table. This is 1.96. So this is the left-hand side and this is the right-hand side. And clearly this time the left-hand side is greater than the right-hand side, right? Okay, so the conclusion is that there is evidence to reject the null hypothesis, right? All right, guys, are you okay with this or not? right? So, I mean, if you can avoid using this, try your best. But in this case, you can because of the large sample sizes, right? All right, guys, any questions on that? Talk to me, guys, please. Are you okay so far on question 3 or no? So, all right, so let's go back to question 3 again. So we just did only the first part of question 3, right? Now, the second part of question 3 is to do the same thing, but assuming that the population variances are equal. So this is where the formula sheet comes again. So you should go back to the formula sheet, right? You should go back to the formula sheet. The formula that we need to use this time is this one, because look here, we are assuming you have two different populations, but the variances are the same, but unknown, right? The variances are equal, but unknown. So in this case, the rejection rule for this is this one. So I'm going to use this to do the second part of question number 3, right? Okay, so let's move on. So let's so this is question number 3, question 3 part 2. So we will reject the null hypothesis if the following is true: x bar minus y bar in absolute terms divided by sp squared is a pooled sample variance greater than this. Yeah, right. Let me put this in a box, right? All right, let me call this star. All right, so I'm gonna show you how to compute the left and the right hand side. Okay, so let's start with the left hand side, right? So the left hand side is equal to x bar. X bar is x bar we know from here is 28.2, right? Y bar is 30.7, right? So in bracket in absolute terms, divided by SP squared. Remember, SP squared is the pooled sample variance, and I gave you a formula for that. I mean, if you look back in my video, you will see a formula for SP squared, right? Which was, if you recall, it was like this. It was m minus 1, which is what m was, 33. Yeah, so it's 33 minus 1 times the sample variance for that, which is 16.36, plus n minus 1, which is 37 minus 1 times 18.92, divided by m plus n minus 2, which is 33 plus 37 minus 2, right? So this is the formula for SP squared, multiplied by 1 over m, which is 1 over 33 plus 1 over 37. Right? Okay, guys, so if you work this out, so what I have got here is the formula for the sample, the pooled sample variance, right? So if you work this out using a calculator, you will get 2.481. Okay. And the right-hand side of star Again, you can use the argument. You can use the argument that the right-hand side is approximately the Z percentile. But this is not so difficult to compute using the t-table. So I'm gonna use the t-table here, right? Which is t. M is what? M is 33 plus 37 minus 2, comma 0.975. Right, so this will be 33 plus 37 is 70. 70 minus 2 is 68. All right. And if you read this off the t-table, you will get 1.995, which is pretty close to 1.96 anyway, right? All right, so this is the left-hand side, guys, and this is the right-hand side. So once again, the left-hand side is this one, this is the right-hand side. So since the left-hand side is greater than the right-hand side, the conclusion is the same. That is, there is evidence to reject. There's evidence to reject the null hypothesis. Right. Okay, guys, are you okay with this or not? Hello, guys, talk to me. You've been quiet today. What's up? So what I've done here is this is the rule that we need to use because we are assuming that the population variances are equal but unknown. So this is the rule that we need to use, right, from the formula sheet I showed you. So I computed the left-hand side, which is given by this, where SP squared is the pooled sample variance, and it turns out to be 2.481. And I computed the right-hand side using the t-table. I'm not sure whether the 68 is in the t-table or not. If it is not in the t-table, you can find something that is closest to 68, right? And if you read it, this is the number that you will get, 1.995. Now, I could have argued that since 68 is a large number, I mean, it's certainly greater than 25, this is approximately the same as the Z percentile, right, which is 1.96. So as you can see, they are not too far off. 1.995 and 1.96, they are not far off, okay? Okay, so, all right, so this is the right-hand side, this is the left-hand side, and since the left is greater than the right-hand side, the conclusion is that there is evidence to reject the null hypothesis. All right, guys, are you okay with this or not? Tell me. So I've done the first 3 questions. So there are 2 questions in the sheet left. They're not really difficult. I'm sorry I don't have the time to do them, but I will post the full solutions to all 5 questions later on this week. So if you go to the course website, you'll be able to see the typed solutions, the handwritten solutions, and the video solutions for all 5 questions, right? Charles, yeah, I think the exam will be open book, so you will be able to see whatever formulas you need. Charles, you can look it up. I think the exam, I think I didn't mention that this morning. Yeah, the exam will be open book, so you should not have to worry about anything you need to remember, Charles. Okay. All right. Any other questions, guys? All right, guys. Have a great morning or afternoon or evening wherever you are. And once again, please feel free to contact me for any questions you guys have by email, Skype, Zoom, or phone. You know my phone number is 0161-273-2941. Okay, right. Take care, guys, and have a great day. Okay.